Hello, my name's Mark and I am G-Code Tutor, and I'm here with Practical Machinist today to continue this Let's Program series. Today we are going to look at drilling our back bore by using a U-drill. Okay, so let's jump straight into it. So we're going to start off with our first line of code and we're looking at an operator's note. So this tells the operator what we intend to do with this following sequence. And we can also add some tooling information in there also, just so the operator can see at a glance what tool we are using and what station it's in. And that N number there I use as a search function. So we're using N9 because this time we're using tool 9 in position 9 on our tool turret. So I always link our search number and our tool number together just for ease of use. So this next line here is our safety line, and I've mentioned this many times before, so I'm not going to go into it in great detail right now, but this sets the machine up to a safe working position each time. So we can jump back into the program at the start of the sequence and not have to worry about any cycles that may be active, such as drilling cycles or cutter compensation, because this line resets everything. Okay, so our next line we're doing a tool call. So as I mentioned just now, we're using the N9 search function number. I'm using T09 with offset position 09 for our tool. So once we type in T09 and the offset position there, and we type MO6, this automatically does a tool change and puts our U-drill onto the center line of the machine, ready to start cutting once this line has been read by the machine. So here I'm setting the speeds, the spindle speed. So we're not using constant surface cutting speed because we're drilling. So I'm just using an S600 speed with MO3, which is the direction of the spindle. So S600 is just a spindle speed I've given it. I've not calculated this spindle speed. By the way, this is just a number I've just put in for the sake of teaching. And the MO3 there is the direction of the spindle that we wish the spindle to rotate to cut on the cutting edge of our U-drill. So make sure you're not running your spindle backwards. Now, if you want to learn more about speeds and feeds, how to calculate the correct speeds and feeds, not like I've just done here and guessed some numbers, I have a full course over on my website called Speeds and Feeds, and that will teach you how to do that. But that course is part of a larger course, a much larger course, where I teach machine shop maths in general. And there's over 9 hours of videos there helping you brush up on your machine shop maths. So if you might find that's useful to you, pop over to gcodetutor.com and have a look. Okay, let's get back on with this lesson. Okay, so our first line, our first movement line, we're using G00, rapid travel command. So we're coming down to X0, our center line, and we have a Z movement 50 thousandths of an inch away from that end face because we've set our datum to that end face there. So we know this is 50 thou away from that face as it rapids in. Now, why I do this in 2 different moves, because the next line is also a rapid move, is I like to see plenty of clearance there when I'm single blocking, when I'm first running this tape, when I'm first trying out this program. I'm going to bring that in with a good clearance, and then on the next line right here, we're coming in to only 6 thou away from that face. So by doing this on 2 lines, it doesn't make your programs any slower to produce the part, but it does add that extra safety margin in there so we can see that we're not having a 2-axis move straight near that face. Okay, so the MO8 on the line above, by the way, turns our coolant on. I always leave that to the last minute. As long as the coolant's up to pressure and the coolant is flooding through the tool before it starts cutting, that's all we need. I don't like to put the coolant on before that, so I've got visibility so I can see inside the machine. Okay, so now we're switching over to our first feed rate move, our GO1, because we're removing material now. So we're going down to X minus 665 there. So that is just 5 thou shy of our finished depth. And I've also issued a feed rate. Now again, I've made this feed rate up. I have not calculated speeds and feeds for this particular U-drill. Okay, so with our machining done and our hole has been bored, we can now safely rapid out. So I'm using G00 again, our rapid travel command, and I'm coming out to 10 thousandths of an inch just away from that end face there. Now, before we move on to the next bit, we're going to look at a little bit of maths, because what we're going to do now is we can use these U-drills as a rough boring bar also. In fact, they can even be used for finish bore, but I prefer to use them only for rough bore and come in with a boring bar. That gives me a little bit more control of our finish bore. Okay, so let's work out how we're going to offset this U-drill. So our final bore size is 0.787 of an inch. Now we can't quite see it at the moment, the U-drill is covering that part of the drawing, but that's what the finished bore size is. Now our U-drill is 3/4 of an inch, so if we take one away from the other, we're left with 37 thou. Now, because we are working in diameters and not radiuses when we're calculating our X offsets, now that's important to remember. So we can take those numbers whole. So we take our 3/4 of an inch drill and we take the size of our bore minus 1 from the other, gives us 37 thou. So that's what we need to offset our U-drill by to make that bore its finished size. But we don't want to come in for a finished size bore because I want to leave some meat on for a finished bore pass in the next operation using a boring bar. So instead of typing 37 thou into our x-axis, I am going to go with 32, and that gives us some material on there ready for the finish pass. So we're offsetting now our x-axis by 32 thou. Then we can drill in again. So now our tool is off center and we're acting like a boring bar and not a drill now. So we're coming in and we're taking off that 32 thousandths of an inch in the diameter. So we're coming down now to Z minus 665 again. So we're still 5 thou shy of the full depth, and that's fine because we're going to remove that with our finishing bore in the next sequence. Okay, so once we're down to final depth with our U-drill, we need to step down back to the center line, so we don't want to drag that tip over that bore that we've just created. So I'm coming back down to the center line there with X0, and I'm still in feed rate mode, by the way, on all of this. We're going nice and slow because we're inside the material. Now we're back to the center line. Now we're not cutting material. Now we could wrap it away. So G00, Z half an inch away from that front face there and turn the coolant off. So we've now got that tool out of the way, nice and safe position there, ready to send home. Now sending home is exactly what we're going to do next. So G53 is our machine datum, and we're going to send it to XZ0. So this sends it to the machine's 0 point and not our datum's 0 point. So this is usually a tool change position, certainly is on my machine, and that's why I'm using this position to change tools. So with our tool safely out the way, now we can stop the spindle by using MO5 and then MO1 for an optional stop in case we want to check our parts. Maybe we want to measure the depth of that bore, make sure we haven't gone over in the diameter there. So with our machine stopped at MO1, we have now finished that sequence, and we can continue now to read the next sequence, which is going to be a finished bore sequence, the final sequence of this series, and that is coming in my next video. So if you enjoy learning about G-code and you want to know more about G-code programming, pop over to my website at gcodetutor.com, where I have 4-course bundle teaching you how to program G-code from beginner to advanced. I've also got some maths courses over there, some CAD to CAM, and some material courses, and lots of other stuff to help you in your machinist career. So pop over to gcodetutor.com to learn more.